Good evening, everyone, or good day, whatever time it happens to be where you are around the world. Welcome, everyone, to Skeptical Inquirer Presents. We're very happy to have you here. Skeptical Inquirer Presents is, of course, a series of live online presentations from experts who are devoted to advancing science over pseudoscience, media literacy over conspiracy theories, and critical thinking over magical thinking. I am Paul Fidalgo. I am the editor of Free Inquiry magazine, and today is April 27th, 2023. As per our tradition here on Skeptical Inquirer Presents, we like to start by letting you know about whatever notable date of observance today might be. And I always have trouble choosing these, but today, for April 27th, the pickings are a little slim, folks. It is National Take Our Daughters and Sons to Work Day. But like many of you, I work from home, so they're already here. It is also National Gummy Bear Day. Gummy bears are now apparently 101 years old. I do believe we are still eating from that first batch. And it is National Poem in Your Pocket Day. That's right, Poem in Your Pocket Day. That will be relevant in just a moment. Intriguing. Anyhow, let me tell you a few things about what's going on here at the Center for Inquiry before we get to the main part of our show. First of all, there's the magazine for which this very show is named. We've got, let you folks know about Point of Inquiry podcast, where we keep the mics plugged in the entire time throughout those podcasts. So every bit of the audio is available to listen for all subscribers. All subscribers get the full audio of that. No mics get unplugged. The latest episode at pointofinquiry.org is going to have me, again, with a plugged-in microphone, talking to Jennifer Michael Hecht. Had a conversation with her about her new book, The Wonder Paradox, all about how poetry can help secular folks find meaning in a very weird universe. And you can find that at pointofinquiry.org. Okay, now, here's what happens now. You are going to sit back and enjoy tonight's presentation. You will become a smarter, better person as a result. That's a guarantee. As you watch, as you learn, as you listen and have questions for our speaker, go ahead and put them in the question box in your Zoom machine. And we will get to as many of those as we can at the end of the presentation. Remember, it's for questions. It's not for comments or monologues or polemics or recipes or anything else. Our speaker today, who you've already heard from, by the way, is Mick West. He is a fellow of the Committee for Skeptical Inquiry and the author of Escaping the Rabbit Hole: How to Debunk Conspiracy Theories Using Facts, Logic, and Respect. A retired software engineer, he's the creator of MetaBunk, which uses crowdsourcing and technical analysis to investigate UFO cases. He's a pilot. He's an airplane pilot, has flown a 400-mile trip solo, which sounds like a great idea right about now. He co-founded the company Neversoft Entertainment, which is responsible for the Tony Hawk's Pro Skater series of games, which I remember particularly well because I was so bad at it. Luckily, I'm a grown-up. I don't care about video games anymore, except, the new Zelda is coming out very soon. Other than that, I don't care at all. Anyway, enough about me and my hobbies. Folks, I am so happy to present to you your speaker for the evening, Mick West. Mr. West, you have the con.
Thank you very much. Thank you very much, Paul. I'm going to get started straight away with a little bit of the old screen sharing. And this should be... Okay, so video game science and UFOs. What is a video game programmer doing analyzing UFO videos? What am I doing? Well, I am portrayed as a UFO expert video analyst, and I'm portrayed this way quite often. You may have seen me on TV, and you sometimes, I'm giving my analysis of a UFO video, or sometimes I'm just giving my opinion about the current state of UFO affairs. But the media apparently thinks I'm an expert. So how exactly did I get into this position? Let's kind of go back in time, and I shall explain. How it began. My first computer was a ZX81, and I was a nerdy kid, and I've been programming video games ever since. I got my ZX81, which of course came out in 1981. I then graduated the next year to a ZX Spectrum. These are British computers, of course, which is why they're the Z. X Spectrum. And then I graduated to an even bigger computer, the Atari ST, which had 1/2 of a megabyte of memory, and a Commodore Amiga, which had about the same. I went to college, but eventually I had, unfortunately, to get a job. So I joined a computer games company. And this was the first commercial game that I ever worked on. It was called Tony Hawk's World Snooker back in 1989, which is 34 years ago, I think, a long time ago. This game is a very two-dimensional game, very 2D. It's just this simple overhead view of very kind of blocky pixel graphics. Really was kind of a fun game at the time. Next game I did was called Rotox. Rotox was a weird overhead rotating shooting game, hence the name Rotox. It used quite a bit of math and geometry to do this rotation. I mean, it wasn't particularly complicated, but it taxed my limited skills at the time. It's mixed polygons with pixel art, so it was kind of a novel thing for the time. And the company I was working at when I made this went bankrupt during the middle of the development, so it was a memorable time. After that, I did some conversions of arcade games. This is a very two-dimensional game, just a side-scrolling shoot-'em-up called UN Squadron, where the United Nations goes into African countries and kills lots of people for some reason. Fun times. After that, I co-founded my own company called Neversoft. And the very first game we did was this one here called Skeleton Warriors. Now, Skeleton Warriors was a bit of departure, and it was a little bit more three-dimensional. You can see the kind of background on the ground there moves around in 3D. And the characters were actually 3D models that were rendered out in 2 dimensions. So it was the evolution of video games. The next step in that evolution was a game called MDK. Which was the first game I did, which was fully 3-dimensional. You see, we have a large 3D world, pretty empty because you didn't have very much memory back then, 3D aliens and 3D ships. So I'm gradually moving from 2 dimensions to 3 dimensions, which will become important later on. Then we did a game for Activision, a big company in Santa Monica, and this was a game called Apocalypse, which stars a character based on Bruce Willis, who at this point is running around a version of the White House, possessed by demons and surrounded by a pit of lava. Typical type of thing you'll find in a video game. And then last, but decidedly not least, I did a game called Tony Hawk's Pro Skater, which this is, Tony Hawk's 4, I believe, but there were 4 versions of it, 5 versions of it that I worked on. I was the technical director at the time at Neversoft Entertainment, and I did a lot of the programming, I did a lot of the physics, and I did a lot of the debugging because there were a lot of bugs in it. Tony Hawk's Pro Skater contains quite a bit of physics. It's not always the most realistic physics. The gravity, for example, is somewhat reduced to the gravity we're used to, so we can get a much better hang time. And the main character is somewhat unencumbered by the hindrances of momentum. So he's able to change direction very, very rapidly, which makes for a fun game, but takes some liberties with physics. So after programming video games for a while, I kind of slid out of the video game industry in the kind of mid to late 2000s, and I transitioned to becoming a writer. The first writing I did was actually technical articles for Game Developer magazine, because all I knew at the time was game development. So write about what you know. This was an article on practical fluid dynamics, which is a very mathematics heavy and very coding heavy way of simulating stuff like smoke and water for use in video games. But then I moved on to other things that interested me, and I was very interested in skepticism and investigating strange claims and things like chemtrails and whatnot. And I started doing more skeptical writing. I started Metabunk, which you heard about earlier. I wrote a book, Escaping the Rabbit Hole, about conspiracy theories. And I write a column for Skeptical Inquirer. And I've looked at all kinds of different conspiracy theories, chemtrails, 9/11 conspiracy theories, flat Earth, election fraud more recently, and like coronavirus-related conspiracy theories, and a bunch of other like conspiracies, pseudoscience, quackery, and things like that. And during the course of that time, I have been gravitating slowly towards UFOs. And so because UFOs has become my kind of main thing that I've been investigating recently, I get portrayed as an expert. And here's me being portrayed as an expert on Brian Denning's upcoming documentary, which is called The UFO Movie They Don't Want You to See, which is looking very nice. It does a good job of showing the various videos I've been investigating and the debunking in a relatively technical way. But yeah, I show up on things like this a lot. I show up on TV, I show up in documentaries, I have a YouTube channel, and people see Mick West being portrayed as an expert, and they get a bit upset about it because they know I'm not an expert. I'm just a video game programmer. And the people who get most upset about this are the people on Twitter. For example, here's a tweet from a couple of years ago. Mick West is no expert. He is a video game programmer. He likes to debunk by selecting straw-man arguments like speed and rotation. So yeah, I'm a video game programmer. I'm no expert. So according to at Shalanzar, this means that all of my arguments should be discounted. Here's another one. Someone says, I'm glad you're interested in the science, but Mick West is a video game programmer. He's not a scientist. I suggest you reach out to professional scientists who have studied these incidents. So again, I'm just a video game programmer. I'm not a scientist. And more specifically, this comes up into play when I'm kind of pitted against somebody else. Like, for example, here, this person here, Cloud Jimmy, is comparing me against one of his favorite scientists, who's a UFO scientist. And he says, this guy has a BS in electrical engineering, a master's in physics, a PhD in optical science, a master's in astronomy, a PhD in aerospace systems engineering, versus Mick West, who is just a video game programmer. Stop being a clown, Mick. I hadn't actually noticed that one before. But yes, apparently I'm just playing a expert on Twitter and on YouTube, and you should ignore what I say and listen to this other guy because he has more credentials than me. Now, we're all good skeptics here. This is the Center for Inquiry. And so you might recognize this as being the argument from authority fallacy. You know, can we say something is true just because an expert says it is true? Well, we know that's a fallacy. So yes, that is in fact a real thing. But really the broader issue here is one of science communication. It doesn't really matter if they pick one expert or the other, because the person themselves doesn't actually understand the science. So using the argument from authority becomes the only thing that they can fall back on. If we can't communicate what the science actually is, then the person has no choice but to pick an expert. And of course, they're going to pick an expert who they prefer. And if all things being equal, they're going to pick an expert who has more credentials. So of course, they're going to pick the guy who has multiple PhDs, and they're not going to pick me, who's just a video game programmer. So the issue really isn't that it's a fallacy. The issue really is about communication, that we need to do a better job at communication. People don't understand all the science, so they pick the expert they prefer. Ultimately, it should be about the investigation. You know, I'm just a games programmer, but if I can do a good investigation based on my game programming skills, you know, that's going to go a long way. So what does make a game coder, a game programmer like myself, a good UFO investigator? Well, let's do a brief list of things that game coders typically understand and are good at. Pixels, the very elements that make up make up an image on screen or a video, the little square things that you see when you zoom in. Surprisingly, a lot of people don't really understand exactly how they work. Things like the resolution of the image, what happens when you rescale it, when you resample it, when you make something bigger or smaller, and things like the colors, like how many different colors you can have. This is called the color depth. How many colors can you have in a pixel, and what happens when you do various things with it? There's 3D math. Of course, when you do 3D video games, 3D math is very, very important. There are these technical things, vectors, which is just a three-dimensional position, transforms, which is a way of moving one position into another position or rotating things and things like that, and perspective, which you all understand. Small things that are far away look smaller, and you have to code that essentially into your graphics. There's 3D physics. When I was doing Tony Hawk's Pro Skater, the physics of the skater skating over the surface and going up ramps and long rails and things is three-dimensional physics. It's very simple, but it uses Newton's equations of motion, and it's typically all you need in terms of physics knowledge to be able to analyze the motion of something in 3D. There's a thing called data munging, which sounds fun, but all data munging is taking data from one format and turning it into another format. Like you've got a JPEG and you want to turn it into a GIF or something like, or a PNG, or you got one set of 3D coordinates and you want to turn it into a version that some software can use. Something you get very good at as a video game programmer is taking data and converting it into other data so it can be used for something else. Human factors. Yeah, this is something you might not think of as a video game programmer, but I'm programming a game and people are going to be playing that game. And so I have to understand the human factors of how they interact with what I do and how I can change my programming. For example, like what happens when you press a button, or what happens when you hold a button down, or you lean the sticks left or right. How do people perceive that? And how do I program it so that they have the best experience? And how do I get over any little hiccups that they might have? There's things that you might be familiar with, like compression, when you take an image and you make it smaller. Video compression, when you take a video or something, you might see little artifacts and little flickering things. These are things that you deal with a lot in video game programming, because we typically use video and we don't have very much memory, especially back in the day. So we use a lot of compression. So I'm used to the way things look with certain types of compression, which is very good for spotting issues to do with compression. Things like frame rate, just it's a standard video game thing. Back when I was a kid, we made our videos at 30 frames per second, and then we would make them at 60 frames per second when things got more powerful, and now they're kind of variable. PCs go like 120 frames per second. Understanding all these different frame rates and how it relates to what we see on screen is very useful for analyzing videos, because videos often come in different frame rates. Sometimes people record at 30 frames, sometimes at 60, sometimes 25. You've got to take that into account when you're analyzing the physics. Debugging is the video game version of debunking. It's figuring out what's going on. And if you get good at debugging, you can be good at debunking. It just naturally follows. And then coding, finally, if you're a video game coder, you're going to be good at coding. And you can use coding to create simulations. And you can use these simulations to demonstrate things to people about your analysis. You can demonstrate your analysis to other people. So I'm going to go for a few examples of how these things actually apply. But first, the most important idea here, I think, with video games versus UFO analysis is that 3D graphics is video analysis backwards. A video game is a 2D video. When your screen in front of you is just 2 dimensions, it's not 3 dimensions unless you've got some kind of VR headset. And so what appears on the screen is a 2-dimensional video. And to make a 2-dimensional video, you take a 3D world with all these positions in this 3D world. Let me just stop this. Oops, I don't know how to stop it, but so you'll take, for example, like this corner here, this corner here, this corner here. They all exist in a 3D world. This one's further away. This one's closer. The skater itself is closer. You need to take these positions in 3 dimensions and convert them to 2 dimensions. Where are they going to appear on the screen? And this is like the fundamental thing you do in 3D graphics is take 3D and make it 2D. So if you've got something like a UFO video, say this was a video of a flying saucer, it starts out as 2D. But what we want to do is figure out, where is this flying saucer in 3 dimensions? What is it doing in 3 dimensions? Is it moving very, very fast? Is it far away? Is it close to you? So you can take that 2D and take the math that you would have used as a video game programmer that converts 3D into 2D and just flip it. And now you can convert 2 dimensions to 3 dimensions. Or at least you can kind of do that. The problem with converting 2D to 3D is that it's fairly straightforward to go from 3 dimensions to 2 dimensions. We've got these points here, they're in 3 dimensions, and we move them along a line towards the focal point, and where they intersect this canvas, which is the image, that's where they end up. So that's very, very straightforward to go in that direction. And it's fairly easy to reverse the same thing. We can say, like, here's the two-dimensional points over here. Here's the eye. We'll draw a line through it, and we know it's somewhere over here. Problem is, we don't know exactly where it is, because when you go from 3 dimensions to 2 dimensions, you're losing 1 dimension. You're using the depth, how far something is into the screen. You know how far up it is. You know how far across it is. You don't know how far in it is. So you can figure out possible locations for a 3D object, but you can't automatically convert 2D to 3D. So it's going to be somewhere along a line of sight from the eye through the 2D point on the screen and out into the 3D world. But once you've got those lines, you can explore the set of possible solutions. Here's an example which might clarify this a little bit. This is a UFO video. This is a video in St. Ives in the UK, Hale Beach. And you can see a little white dot here, just kind of moving along, and it kind of hovers here for a while. And then in a second, it's going to shoot up into the sky. So we have something comes from here over to here, and it's going to shoot up into the sky. So this is a UFO. And when people look at this the first time, they think, oh my God, it's like this craft that's over on the horizon, because it's just above the horizon. And then it shoots up into the sky at incredible speed. So it must be some kind of amazing flying saucer. The question though is, like, is it actually far away? Is it near or far away? So we can do the analysis I just described on this particular 3D video. There it goes, shooting up into the sky like a rocket. This would be like a rocket if it was several miles away at the horizon. So what we want to do is try to kind of set up a simulation so we can see exactly what might be happening. So I figured out where the camera was, and I'm fitting this field of view to it so I can figure out what it looks like. And then I extract the 2-dimensional positions of the object using motion tracking. This actually in Adobe After Effects, it figures out exactly where the objects are as it moves along the screen and gives you a whole bunch of 2D positions. And then we can do the deprojection of these positions to convert it to these lines of sight along which the object might actually be. Let me quickly go to the interactive version of this. And this is that setup here. We have the actual video here, and we have a recreation of the video down below, and we can kind of scrub through it here. We can see it move along. So we can see it move in the original video, in the recreation, and in this 3-dimensional version of it. Now, the 3D version is set up at the moment to have the object just over the beach. So we can ask ourselves, is this a physically realistic thing for it to do? And you can see it move around. And up here, I've set up a graph using the 3D physics that we would use in video games to figure out how fast it's going. Turns out it's going very, very slow, less than 10 miles per hour if it's over the beach, which is very consistent with something like a drone. And if we were to take the distance of the object and make it further away, we can see that the speed very rapidly increases into realms that are somewhat implausible for something that's just a hovering object. So we get a range of possibilities based on just adjusting the distance in this 3D model. They all look pretty much the same, but some of them are more realistic than others. So it gives us what might have happened and what is the more plausible explanation. Yes. Oops. So you can see here, the setup in 3D was very similar to what we had here with this little projection here. We had the same thing here. This is where the camera was, and this is the lines of sight, and these are the possible solutions which we've set up. And we found ones that are physically more realistic, and so that becomes the top of the list. Now, 3D physics, a fundamental part of game programming is this simple 3D physics. And physics in games is basically you store the position of the object, you store its velocity, like how fast it's moving and what direction it's moving. You have various forces acting on the object, including user input. So when you press a button, it makes them jump up. And you basically just add all that together in the proper way and figure out how that object moves. And in Tony Hawk's Pro Skater, that object is a skater. It's 3 dimensions. There's these thing called vector arithmetic, a little bit technical, but very straightforward, really. You use standard equations of motion, which you might remember from school. S equals ut plus half at squared. Anyone? Yeah. You use a thing called Euler integration, which sounds complicated, but it's just basically adding numbers together to get where the skater will be in the next frame, and a bunch of other things. A quick example of 3D physics is the jet in the gimbal video. If we go to that video real quick, let me see, gimbal. All right, so this is a very complicated situation, but I want to focus on one small aspect of it. There's a video down here, famous gimbal video, and it's basically, it's filmed from a jet, and we know that the jet is banking to the left, and we can kind of extract these values of the jet and figure out, what the bank angle is. And what I did then was do a simulation, a little 3D physics simulation of the jet. And we'll see it kind of reappear right here. Turn the jet on. So here's a little jet flying along with the bank angle matching this particular angle here. And we simulate its position, which then allows us to take other numbers and simulate the lines of sight, and then calculate all these other things, and all this radar and these various graphs and all this different analysis. But it's all based on doing a very simple physics calculation, which is essentially implementing a very, very simple flight simulator. But essentially, it's something that you would do as a video game programmer. It's a very typical type of thing to do a simple flight simulator. Pixels example. Pixels, old school video game programmers like myself were very familiar with pixels. And this is the gimbal video. Okay, same one we just looked at. And I'm zoomed in on one frame, and you see these kind of weird spikes, kind of like ripples. So what's actually going on here? Well, let's actually have a quick look at the pixels. I've got a video viewer here that I can use to zoom in very nicely. So if I zoom in all the way, we can see the pixels are actually just, these little squares. And when I go to that particular frame at the end, we can see it's not actually a bunch of curves. It's just a bunch of individual lines that are offset alternatingly. And you might recognize that as being a thing called video interlacing. Back in the day, TV displayed every other line alternating frames. So you would often get these kind of jaggy artifacts between frames. And this is what we're seeing here. We're seeing some video interlacing. But what happened was a scientist with 2 PhDs did a faulty interpretation of that. He took this frame of the video, and he said that what we were seeing were optical interference fringes. Now, the version of the video he took was actually a lot worse than the one I just showed you. It was the one he downloaded off YouTube. So the end result was this kind of strangely smooth curve thing, which he did some analysis on. And he thought that this would allow him to calculate the size and the distance to the UAP, the UFO. Problem was, of course, that what he had here as his input material was nothing at all like the actual image. And so garbage in, garbage out, he did an analysis which was 100% wrong. And this was a person with 2 PhDs. So sometimes, people with PhDs get things wrong. All right, on a slightly less technical note, I don't want to overload you with technical stuff. Human factors. We did a lot of focus tests like this one here. You kids don't know what you want. That's why you're still kids, because you're stupid. We did a lot of focus tests with our video games. We'd watch kids and adults play the game, and then we'd ask them about their experience. And we found that a lot of people have trouble describing what their experience was and what they felt about it and what they thought would be an improvement. If you ask someone, how do I improve the game? They'll tell you something that generally doesn't make sense. And with UFOs, I've experienced similar things. People are trying to help, but they often tell you things based on what they feel is right rather than what is actually right. So you have to learn to kind of recognize that and get around it. Here's an example. I was sent this video. There's a small version and the zoomed in version. by a Korean correspondent, and he said that a witness had seen this weird UFO high up in the sky, way up above him. So I asked him to redo it in daytime, and he sent this image, which wasn't from where he took the thing, showing where he thought he was and where he thought he was looking, and then a picture possibly from there showing where he thought the UFO was, just like up there in the sky. So I asked him again to do it, and then he sent me this diagram with Korean notation. I guess that says phone lines and various other things, but not very useful. And then somehow they managed to get the power company to come around and examine the power pole, and they took some other photos. None of those were from the right location, though. So even though I'd asked them very specifically, give me a photo from where you took the photo, they somehow couldn't do it. But I managed to analyze the original video and boost the levels by kind of adding the frames together, and something kind of showed up right there, and we can kind of see roughly where all the power lines and things are. I was able to kind of distort this, even though it wasn't from the right position, and it kind of showed up that it was actually right by the wires, despite him insisting over and over again that it was nowhere near these wires. Turns out it was actually by the wires. And it turns out that what we were looking at was just a little clip on the wire. So, when you're talking to eyewitnesses, they're usually very honest. They're usually trying to help, but they often make mistakes. And this is something that, I've experienced a lot with people trying to describe things in video games. And that experience has been very useful in talking to people politely, because you have to tread carefully when you're kind of saying someone might have made a mistake. Here's a more complicated example. This is the Aguadilla video, a UFO video. It's shot by a Coast Guard in a plane that was circling the Aguadilla airport in Puerto Rico. And it was tracking this weird flying UFO. So here we've got a 2D video. Can we take this 2D video with all these very nice background, little houses and runways and things like that? Can we take this 2D video, convert it into a 3-dimensional world to see what might actually be going on here? Well, this is a great video because it has a lot of data on the screen. We have the camera position in latitude, longitude, and altitude. The camera position is right here. So it says aircraft. And that's the latitude, that's the longitude, and there's the altitude. So that's really, really, really very useful for a reconstruction. We also have the target position. It says over here, target. So it's saying what we're looking at. Now, this isn't actually the object itself. This is what's the ground, what's on the ground behind this crosshairs here. But, also very useful. We have a very detailed background, which we can use to geolocate things more exactly. If something doesn't exactly line up, we can say, like, here's a road. Where is that road? Does it match these coordinates? It's a wonderful video in terms of the amount of data in it. 7,000 frames of data. So what we can do is go through all 7,000 frames of data. We can type in the coordinates from each of the 7,000 frames of data, and that will be a great data set. Luckily, it was already done. Somebody already went through it. They kind of crowdsourced it. A bunch of different people did it. They did it back in 2015. They made a 7,000-line spreadsheet on the Above Top Secret forum. Amazing effort. And it came out to be this wonderfully useful piece of data, which we can use for reconstruction. So we've got these 2 data sets here. One is the planes track, and the other one is the target track. Both of them, of course, are somewhat noisy and low resolution. So we're going to have to do a bit of munging on these. So here, these little white dots represent the actual recorded positions of the plane. Now, planes don't fly in zigzags like this, so we have to use a kind of our general knowledge of physics and how a plane might bank to, again, with our 3D geometry and our munging skills, to create a path that smoothly goes through these points. And this gives us a nice camera position, essentially. Next, we've got the target track, which is terrible. It's just this weird squiggly thing. We can't really do very much with it. So what I did there was something you have to do in video game programming, which is create a custom tool to edit the path. And I did that with basically a spline editor. We've got here the original video. We've got my simulation of the video. We see it doesn't quite match. There's the road here, the road down there. Didn't quite match before. So I moved this position of the path. Now it matches. and then keep doing that for the entire thing. And we eventually get a path of lines of sight which matches the what we see in the video. We get a replication, we get a simulation exactly the same. Now we can use that to start analyzing what's going on. So let's have a quick look at that in the interactive way. Aguadilla. So this is software that I wrote. It's also available online. You can run it in a web browser. Again, it's got the actual video up here. It's got the simulated video down here, and it's got all the lines of sight. This line here is the path of the plane. This kind of bluish line down here is the reconstructed lines of sight. And then we can use that. The blue lines are all the lines of sight, and we can figure out a way of going across these lines of sight. And this green line here ends up being the very simplest way you can traverse the lines of sight. And it turns out that if you start here and you go to here, starting about 18 miles per hour, kind of descending gradually, you get a trajectory which solves this problem perfectly. Now, of course, there are other solutions. There is this red one down here. This will be something that is moving down by the surface and not actually moving high in the sky. Like this green one is actually fairly high up above the runway. And the red one is low down to the ground, and it actually goes underwater at various points over here. So we have to ask ourselves, like, which one of these two is more likely? We've come up with some solutions. One is physically very plausible. The other one kind of maybe looks more exciting, but is it actually something that's plausible? So with that, we end up having two possible solutions, and then we have to kind of do our analysis of those and perhaps do a bit of human factors. Why does this super fast thing whizzing over the ground look more enticing to people? Well, it looks more enticing because that's what the video actually looks like. The video looks like something whizzing over the ground. But is this 18 mile per hour version plausible? Well, it turns out that just upwind of this location, there is a hotel about here, just off the map here, where they release wedding lanterns, these so-called Chinese lanterns or sky lanterns or fire lanterns. They're just kind of big paper bags, and they've got like a little bit of burning fuel in the bottom, and they will release them here. Normally they will go out to sea, but the wind that day was blowing over the ocean, over the airport. So it seems quite likely that a couple of very low speed sky lanterns were just drifting over the ocean, and this plane was just flying around them and making it look like they were zipping over the ground in some kind of weird way and going underwater and doing all kinds of weird, physically implausible things. So we end up with two hypotheses, one of which is more physically plausible, but the only way we got there was by doing a lot of programming, a lot of analysis, and a lot of things that were based very much on my game programming experience. So, in summary, video game programmers, it turns out, are actually well suited to UFO analysis. People with PhDs sometimes get things wrong. We all have different knowledge domains. I know a lot about 3D graphics. I know a lot about pixels. I know a lot about basic physics. And someone with a PhD in physics will know a lot more about, say, I don't know, quarks and muons and electron levels and things like that. And they probably will know the basics too as well. But their area of expertise is perhaps not always appropriate for analyzing simple UFO videos, where basic physics actually is more useful. The problem, of course, is that people are going to dismiss analysis that they don't like, no matter where it's from. It would be great if we could get all the UFO believers to watch this video. They'll see it and be like, oh yeah, great, Mick's really good at coding and he's really good at analyzing UFO videos, but he's maybe even better than this guy with the PhDs. But I prefer the other explanation. If there are two good explanations and one of them is something that they like better, they're just going to go with that one. So really, it's about how well you analyze the data and how well you present that data in an understandable manner. You've got to do a accessible presentation of the data. You can't just say, I'm an expert. I can't just say, I'm a highly qualified video game programmer or a highly qualified guy with 2 PhDs, and I think that it is this. You've got to do a compelling looking and accurate and honest analysis and a presentation of that data. And that's something where video coding experience and an understanding of human factors can be very useful. It is very useful to in both the analysis stage and in the presentation phase. And this is something that I've really enjoyed doing, and I'm going to continue doing, I think, for the foreseeable future. And hopefully, I will convert a few more people. Well, so that's my presentation. That's all the examples that I have, and so I'm now going to open it up to questions from the audience.
Oh, thank you so much, Mick. This is so interesting, and you know, on a technical side, it does seem pretty overwhelming, and I do want to ask you a little bit about that. But before we get to some of that stuff, why did UFOs become? How did that hook you? Was it because of the video game angle, or did you already have an interest in the topic of extraterrestrials and things like that?
Well, UFOs are one of the things that had always kind of existed on Metabunk as a kind of a background topic, but they kind of really came into prominence in around 2016 when there was a kind of a semi-famous case called the Chilean Navy case, which apparently the Chilean Navy spent 2 years analyzing, trying to solve this case, and they couldn't do it, so they released the video. And then Metabunk ended up solving the case in just a week, which was a lot of fun. I really enjoyed that particular case, and that kind of got me really much more interested in doing UFOs. And then it kind of coincided with this kind of national hubbub around UFOs starting in 2017. With the New York Times publishing an article on UFOs and various UFO videos being leaked or released from the US Navy. And so I got into analyzing those, and because they were such well-known videos, there was a lot of attention on them. And so it was very interesting and challenging to do analyses of them. So that's kind of how I got into it.
And I take it you have not yet been contacted by members of Congress to help with their ongoing UFO investigations, because it seems like you'd be the guy to ask.
Not yet. And I think this kind of boils down to the fact that I'm just a video game programmer.
Okay. Sorry, please. No, go ahead. Go ahead.
Yeah, I think, the people who are serious people, they don't have very much to go by in terms of like picking experts. So if they just want to go by someone's resume, they will obviously pick the person who's got multiple degrees, multiple PhDs or whatever. But if they actually look at the results, if they actually look at all the things that I've done versus what other people might or might not have done, then they might pick me. But of course, they don't have the time to do that. These are serious people, generals and whatnot, doing serious things, and so they just kind of have to say, all right, we'll find someone who's got a PhD who has published about UFOs in a academic journal, and we'll go with that guy. And someone's, but I saw this amazing YouTube video by Mick West, and they go, what? No, we're not going with some YouTuber. What does he do? He's a video game programmer.
On YouTube.
No, yeah. So it's an issue. It's an issue. I can't actually do any serious work for the government. Not that I'm really seriously thinking that I would, but it's not helpful that I'm just a video game programmer.
Well, it's interesting because one of the questions we just got in from Keith here, he asks, he says he's curious why you don't consider yourself an expert despite your obvious skill set. And I understand you don't necessarily have the
I do
PhDs, but yeah,
I do consider myself an expert in that I've analyzed a lot of UFO videos. So I'm an expert in this field, but people don't realize that it's something you can be an expert in without having something else to be an expert in. Like you'd say, you have to be an expert fighter pilot. I'm a pilot, but I've only just done the basic training and the basic long distance solar. or you've got to, you've got to be someone who's published scientific papers. Like this guy's published like 100 scientific papers, so obviously we'll go with him. So yes, I'm an expert, but not in a recognizable subject.
That makes sense. And one of the folks who also asked a question, Thomas McQueen, asked, have you shared your analysis with the dual PhD? And did they acknowledge the shortcomings of their own analysis?
Yes, I did. And yes, they did. And they did ask me to kind of hold off on publishing my analysis of their analysis, but that was about 6 months ago. So I think enough time has passed since then. But yeah, people, if they go out there and they publish something and it's available to the public, I think they're going to expect criticism. I think it was a bit unhappy that I kind of so quickly explained what the issue was, and it was kind of a rather egregious error on his part using the wrong graphics. But yeah, we move on. I'll keep doing my analysis, and I'm sure he will keep doing his analysis.
That actually brings up a question for me. Is you mentioned how like you're crowdsourced that one video, they said it took about a week. When you're working on one of these on your own, what is the time commitment for this kind of thing? This looks like it must take ages. That's how it looks I know nothing. So that's what it looks like to me.
Yeah. I mean, I spend a lot of time doing it, but I'm essentially retired. And some people spend a lot of time building model train sets. Some people spend a lot of time watching television. A lot of people just sit in front of the TV all day. I spend a lot of time analyzing UFO videos and making 3D reconstructions, and then making educational videos explaining what I've done, which I think is a not unreasonable use of my time. I mean, it's not a great career or anything, but it's fun and it's interesting and it's educational and it's even helpful to some people.
Well, we're pretty glad you're using your time for it. It's pretty good for us too. We have actually a few really good questions here, and one that I actually wanted to get to. So I'm glad, Scott Snell, thank you for asking this one. Computer generated fake videos of UFOs are likely to be harder to debunk, he says, as the technology improves. And I'm wondering about that. We see a lot of people doing these AI generated videos now that are just on demand. I mean, they just get churned out. So he asked, does your expertise give you an advantage for analyzing those? And I'm just curious if those really are harder to do, as he says.
Yeah, they are hard to do, but this is an issue that already existed. We already had UFO videos that were indistinguishable from potential reality. Obviously, they look like weird flying saucers, so they're probably not real. But what you do there is that you start off with the provenance of the video. Where did it come from? Give me the original in-camera original file. And do we have any other witnesses? Do we have any other footage? Like if it's this amazing ship flying over New York, you'd think that more than one person would take a video of it. So we've already got kind of a process in place for kind of authenticating a video. And if it passes those steps, then you get into the actual, down in the pixels and the 3D analysis. But there's already a lot of fake videos, and I see them all the time. They're usually pretty blurry, and they'll probably get better in the future. But if there's not a real person behind it who claims that they took it, and they can't produce the camera that they took it on, and they can't show you the memory card with the file on it, and you can examine that original file, then I usually don't even bother.
Oh, that's interesting. So in the end, it comes down to can we verify that a human person was there taking the video? Or
very much so. Yeah. And that's why the US Navy videos are so good, because they were taken by someone in the US government, by an actual Navy pilot. And so that's very good provenance. And we even have chain of custody for these videos to a certain degree. They came out of the Pentagon. So these are ones that are worth investigating because we know they are genuine. Other ones, like slightly less worth investigating. There's a famous green triangle video which was leaked. It wasn't an official thing, although it was confirmed eventually. But if something is just a leak, it's a bit less likely to be real. And then the endless videos you see on TikTok and whatnot that are almost certainly fake, but there's no one claiming to have actually made them, so not worth looking at.
Oh, that's really interesting. That's funny how you just to start at that square one right there, it simplifies it so much. We're getting a couple of questions along these lines, and I share this question as well. Has there been video footage where you have been genuinely stumped and you're thinking like, whoa, wait a minute, what is going on here?
Well, yes and no to those two questions.
Okay.
The first question was like, am I genuinely stumped? And often you get a video where there's simply not enough information in the video to make a determination of what it is. You could possibly come up with some hypotheses, but you can't demonstrate that it is actually that thing. Now, something where I'm like, whoa, what is that thing? Doesn't really come up. Like, some things are kind of interesting, but they're usually things just like little white dots that are moving around in a strange way. You're not going to get like your classic flying saucer, like, hovering in and then zipping off into space. Like, that would be something that would be very hard to explain. But all we're seeing is just like a little dot going flying around. It's on someone's Ring camera. It looks probably a moth or something like that, but you don't know what it is because it's so low resolution. There's this concept called the low information zone, the LIZ, the LIZ, where UFOs exist, which is just the distance or set of circumstances at which you just can't tell what something is.
Right.
And that's where UFOs all exist. There are no UFOs that are close enough where you can actually, get a good photo or video of this actual UFO. It's always going to be just so far away that you can't tell what it is. And then if you get your better camera out with your long zoom lens, you'll see what it actually is. It will resolve into a plane or a bird or whatever. If you don't have your better camera, it stays in the LIZ. It's always going to be unknown. And the fact that everything that comes out of the LIZ gets resolved is a pretty big clue that most of the things in the LIZ, in the low information zone, are probably pretty boring things too, unfortunately.
So Chris Garner asked this. So what would you say is the ratio right now? I mean, you probably have to spitball this, but the ratio of videos that you've worked on that are mistaken identity. Oh, I thought that was a thing and it's not a thing, versus a hoax or a purposeful fake.
I'd say it's well over 90% like genuine, like mistaken identities.
And that's interesting.
Partly because I ignore a lot of the hoaxes.
Mm-hmm.
And they just don't get very far. People recognize them. If someone posts an obvious hoax video on Reddit, they're not going to like send it to me and ask me what I think. But people send me their own individual videos. People do not send me their own individual hoaxes. They're not going to hoax something and send it to me because I'll probably figure out that it's a hoax and just say so. When someone hoaxes something, they anonymously upload it to TikTok, which is your big clue. And I just don't spend much time with that. So the vast majority of the videos I look at are real UFOs, in that it's something that somebody could not identify and they're asking me to help, or indirectly someone ends up asking me what I think about a certain video.
Returning to the videos from the U.S. Military, the Navy videos, a couple folks are asking about those, and I don't think that we have time for you to like do a full discourse on your opinion on them, but maybe you could just kind of give us an idea of what your opinion is about what we have seen and how authentic. I mean, not how authentic it is, but like what is the kind of thing that we really think we're looking at here.
Well, there's quite a variety of things. There were a couple of videos released recently, but during the I think it was the Senate hearing, was the congressional hearing, the most recent hearing in government, where they showed two videos, one of which they identified as a plane, and the other one is just kind of an orb, which appears to be moving very, very rapidly. And essentially, these are LIZ videos. These are low information zone videos. They showed this one video, which ended up being a plane. And they said originally when we looked at this video, everyone thought it was truly anomalous, which was rather strange because it didn't look super anomalous to me. It was leaving this weird trail behind it. Mm-hmm. It was pretty obvious that it was just some kind of image, either compression artifact or a sensor artifact, because it was just leaving an image of the plane behind itself. And then it kind of looked a bit like a plane. You could see a bit of the tail and stuff like that, and you could see the engines glowing in infrared. So it was a little surprising that they used that as an example. And then the other one was just this kind of, again, just like a shapeless blob, kind of an orb type thing. It looks a bit shiny, and it looks like it's moving very rapidly, but it could very well just be the parallax effect on the plane moving past it, like with the Aguadilla case that I showed earlier. Unfortunately, there's far less information in that video than there is in the Aguadilla case, so it'd be very tricky to do a 3D reconstruction. You'd have to kind of speculate a lot about what's actually there.
So on a video like that, that's not making you, as someone who is used to picking these things apart, there is this like an example of a video where you're just like, well, it's not enough information, what can I do? Or is there ever like a little heebie-jeebie feeling that you get of like, oh, I don't know what that is, that's weird? Does that ever come up for you at all?
No, because the more mysterious a video is, invariably the less information there is in that video and about that video. So in this more recent orb video, it's kind of interesting, but I did some analysis of it. You can tell that before the orb flies into view, we can see it's a video taken from a Reaper drone, one of these very large winged drones. And we can see that it's actually moving because the shape of the building changes a bit. So we can tell it's moving in that direction, and then the orb flies in the opposite direction. So it kind of looks like parallax effect. You can do a very simple observation of the fact that it's about the size of 2 telegraph poles in width, which gives you an upper bound on how big it could be. It can't possibly be bigger than the width of 2 telegraph poles, because if it was bigger, it would look bigger. If it was closer, it would look even bigger. So we can get an upper bound on that. So there's some very simple analysis you can do to get some parameters. It's probably something like a balloon drifting in the wind, but we can't say that for sure. We can say that's a possible hypothesis, but there's not enough information to really say for sure. And it could be something else. It could be an amazing anti-gravity craft that's being used by the Syrians to do whatever. But we don't know. We don't know.
Martin Heinsdorf asks, it looks like some of the techniques that you use can be used for videos for ghosts or other magical events, and wonders if you use your expertise in debunking this kind of stuff as well.
I do occasionally look at ghost videos, not so much recently, but I have done that. But yeah, that's something where you're basically, again, trying to do a reconstruction of what happened. So you look at the environment and you see what direction you're looking in, and you see, what could exist in that space that could explain, what we're seeing. So it is somewhat similar, but usually ghost videos are less precise than UFO videos. You don't have a craft flying around in the sky. You just have like a shape or something like that. And it's more often you see ghost photos than ghost videos. So that they're kind of fun to analyze, but it's not really the same thing.
Yeah. Now, this is an interesting question. I was, as you know, I'm watching the thing and I'm going, wow, this is a lot of technical stuff and I don't understand it because I'm not that smart. We've had a couple of folks who have written in to ask, where can we get more of the technical side of this presentation? We have one question asking, is there a full presentation that is more of the technical stuff? But also some questions about like, where are some other resources they can go to, particularly the software that you mentioned, I believe.
Yeah, the software... the software is called SITREC, SITREC, Situation Recreation. And you can find it at metabunk.org/SITREC. And it's just a web app. So it runs in most browsers. Yeah, for some of the video versions, you will need to use a browser like Chrome. It won't necessarily work in Safari or Firefox. So just use Chrome. Everyone has access to Chrome. And if you want to learn more of the technical details, there's a whole bunch of discussion threads of various aspects of it over several years on Metabunk. So you can just do a site search of Metabunk for SITREC, and you'll find a variety of threads on the subject. And if you've got some specific technical questions, I'm happy to give quick answers to them over email. You can mick@mickwest.com, or you can find me on Metabunk or on Twitter.
Perfect. And does there exist a presentation in which you do even more of the technical stuff than you did for us today?
No, there isn't.
Well, now there's a demand.
Yeah, there is. Yes, and I've done technical presentations before. I wrote a refraction simulator for the Flat Earth people a long time ago, and did a very technical presentation of that. That was, in some ways, more technical because it used these complicated physics equations to ray trace lines of sight through the Earth's atmosphere. But yeah, so if you're interested in technical presentations, there's one on a different topic. But
how was that received?
Well, the flat Earth people thought it was all lies, and the flat
Okay,
Earth
good.
skeptics were found it very useful because you could use it to recreate images that people thought were impossible. Like, for example, flat Earth people, they like to observe that if you take a laser, you can shine it across a lake, even though the curvature of the lake should obscure that laser. And what's actually happening is that the refraction is very strong near the surface of the water, and they will bend the laser basically sometimes over 20, 30 miles to the other side of the lake. And I could simulate that but we're getting a little off topic here. It's
good. No, this is exactly what you should be. This is what they're asking for. This is what the people are demanding. But also demanding is the clock. The clock has told us it is past our time. So I will say, Mick, thank you so much. They can find you at metabunk.org. Yes.
Yeah.
And also, he is a columnist, folks, for Skeptical Inquirer. So you can find his stuff at skepticalinquirer.org. I even wanted to ask you about like the UFO sightings in Ukraine that you said were flies and that Avi Loeb said was not. There's lots of great stuff happening over there. So find Mick all over the place there. Thank you so much, sir. Thank you to our producer behind the camera. You can't see Mike Powell at CFI. Most of all, thank you, everybody, for taking the time to listen and learn and think and ask questions. Inquiry, it's what we do here. It's the name of the game, folks. So good to have you all with us. If you want to enjoy this program over and over and over again, you're in luck. The video will be posted probably some point tomorrow, right online at skepticalinquirer.org. So thank you again, Mick, and thank you all again. And good night.
Good night. Thank you.